In this video, we will learn about inverse trigonometric functions and the basic concept involved in their graphical representations. The inverse functions of the trigonometric functions of sine, cosine, tangent, etc. are termed inverse trigonometric functions. They are basically used to obtain an angle from any of the angle's trigonometric ratios. They are denoted by sine inverse x, cos inverse x, tan inverse x, sec inverse x, cosec inverse x and cot inverse x. Mr. Mayank Maheshwari from Puran Chandra Vidya Niketan, Kanpur will tell us more about this topic.
Today we will study inverse trigonometrical function. We know that inverse of a function is defined only when the function is 1 to 1 and onto, that is if it is a bijection. As far as we know about the trigonometrical function, say sin x, we know that its domain is all real number and its range is from -1 to 1. To define the inverse trigonometrical function for sin x, we need to restrict our domain, and with its domain, when we define sin inverse x function, we know that its value lies between -1 to +1. For positive values, that is from the values from 0 to 1, we use the first coordinate, and for the negative values, that is from -1 to 0, we use the fourth coordinate, and hence the domain and range of the inverse trigonometrical function fx is equal to sin inverse x is given by domain as -1 to 1 and its range is -π/2 to π/2. This is also called as a principal value branch. Similarly, for cos inverse x, we get the positive values from the first coordinate and the negative values from the second coordinate. And hence, also we know that cos x used to vary from -1 to +1. So the range of fx is equal to cos x was -1 to 1, and hence the domain of the domain of the function cos inverse x will be -1 to 1, and of course its range is from 0 to pi. This is also called as the principal value branch for cos inverse x. Similarly, for fx is equal to tan x, we know that its domain is all real number and its range is also from -∞ to infinity, that is all real number. The domain of trigonometrical function fx is equal to tan x is all real number except for odd multiple of π/2. And its range is from -∞ to infinity. However, when we define inverse trigonometrical function for tan x, that is for tan inverse x, its domain is -∞ to infinity, whereas its range is from -π/2 to π/2, both being excluded. Also, we know that the graph of sin x, the function sin x, is of the form like this. It varies from -1 to +1. And if we draw the graph of for sin inverse x, its graph comes out to be like this. Over here we have π/2. At π/2 we know that sin x becomes 1. So at sin inverse π/2 we have 1, and at sin inverse -π/2 we have -1. So the graph varies like this. This is its boundary. It won't go beyond 1 and beyond -1. Similarly, when we talk about the graph of cos x, its graph starts like this and goes like this. Its value is 1 at x is equal to 0, and at x is equal to π/2 it becomes 0. At x is equal to pi it is -1, and at x is equal to 3 π/2 it is 0, and at x is equal to 2 pi it is 1. If we draw the graph for cos inverse x, its graph will be somewhat like this. At x equal to 1, at x equal to 1, it is 0. At x equal to 0, it is pi by 2. And similarly, as the case of sine inverse x, the graph lies between -1 to 1. Similarly, the graph for tan inverse x goes like this. At x equal to pi by 2, it becomes infinity. So the graph becomes asymptotic at x equal to pi by 2. And similarly, at y is equal to minus pi by 2, it goes to minus infinity. These are the graphs for sine inverse x, cos inverse x, and tan inverse x. So we define inverse trigonometric function by restricting their domain and range accordingly to make it a one-to-one onto function.
The inverse of a function f denoted by f inverse exists only if f is 1 to 1 and onto. Domain of sine inverse is from -1 to 1 and its range is from minus pi by 2 to pi by 2. Domain of cos inverse is from -1 to 1 and its range is from 0 to pi. Domain of tan inverse is -infinity to infinity and its range is from minus pi by 2 to pi by 2.
For more such videos, log on to CBSE section of jagranjosh.com.